So in this video, we're going to use the NanoVNA to have a look at some coaxial cable and try to work out the distance and also the loss of that particular cable. So here we are in NanoVNA-App. You can see here that I've got the NanoVNA connected to COM port 8. In a previous video, I showed how to use this connected to an antenna to measure SWR and return loss. I also showed how to connect the NanoVNA to the PC. So if you want to see that, you can go back and review that video. But for now, what we want to do is we want to connect this to the time domain reflectometer graph, which will show us a pulse to see how long our particular piece of coax is. So what we want to do is we want to right click and we want to go to graph type, and then we want to go down here and select TDR linear low pass impulse S11. And when we do this, you can see here at the bottom that now we've got a length in meters, and we go all the way up to 20 meters. Now, if we want to adjust this graph so that we get a little bit more resolution, what we can do is we can go up here and change the frequency. So at the moment we're sitting between 5 and 600 megahertz. If we actually change this down to 300 megahertz, you'll now see that we've got more distance, 42 meters, so we'll have less resolution. If we go even lower, so if we go to 30 megahertz, we go all the way up to 500 meters. So you will need to roughly know how long the maximum amount your cable is going to be able to measure this. So for now, I know that my piece of cable is less than 10 meters. So what we can do is we can go in here and we can change these frequencies. In actual fact, we can lower the start frequency down to 1 and our stop frequency to 700. No, we can go a little bit more than that. 800, no. 900. We might actually need to adjust this length a little bit until you get it where you need it to. I think that's going to be fine. We might try, see if we can get it. 1500 is way too much. 10 meters, there we go, 1200 megahertz. So now here at the bottom, you can see that we've got a pulse sitting here. If we go into calibration, I've already done this calibration for the short, open, and load on this NanoVNA. Once the calibration's set, we need to go up to this drop-down box up here and set the TDR velocity factor. So if we drop this down, you can see here that there's all sorts of different coax listed with their velocity factors. So we've got RG58 here of 0.66. We've got RG213, different versions of RG213 have different velocity factors. We've got LMR 400, LMR 400 Ultraflex, and then we've also got here the Messiaen-Poloni cable, Ultraflex 7, 10, EcoFlex, etc. Now the cable that I'm using is Hyperflex, so if we actually go and open up the data sheet from Messiaen-Poloni, we can find out what the velocity factor is. Now just quickly, Messiaen-Poloni cable I use extensively around the shack here. I also use it for a lot of my microwave equipment. It is great flexible cable that you can use for all sorts of different uses. If you want to get a discount on this cable, then I offer 10% to my viewers, and you can check the description below for that. So if we scroll down, we can find the velocity factor is 86%, so 0.86 sitting right there. So what we can do is we can go now back and select our velocity factor, our custom velocity factor. So just select custom here in the drop down and then 0.86. So now all that we need to do is we just need to make sure that we're in continuous scan, which we are. And you'll see that there is a pulse here right at the 0 point, which is showing pretty much the pulse coming straight out of the device and coming straight back because we've calibrated it to the end of the connector on the NanoVNA. So if I connect now our cable to the S11 port, you'll see that I've got now a nice pulse here sitting at 7.357 meters, 24 feet, which is roughly about what this cable is. What we could do is now we can then confirm this. If we want to measure the cable, then we can do that. But this gives us a very nice indication of what the cable length is just by using the TDR functionality. So not only can we measure the distance of our cable, but we can also measure our coax loss. So if we right click here and we change the graph now to coax loss, S11, this will show us our coax loss. Now, because we've changed the frequency, we're actually now measuring frequency, we're going to have to go and recalibrate. So what I'm going to do is I'm going to disconnect my coaxial cable, and you can see there that we don't have a nice zero line. We've actually got this dip going on here. So we've got to go back up to calibration, reset this, and run through our calibration again from 1 to 1200 megahertz. Right, now that we've calibrated it, you can see that we've got a nice zero line. So if we actually plug our cable in now, you could see that we have our line goes all the way here from, 1 megahertz all the way to 1200 megahertz. And you can see that the line gradually goes down as we look here on the left-hand side. We've got our dB measurement, and we've got a live measurement there in the top left-hand corner, which tells us basically how much loss we've got in our cable. So we could see there that this is a very good way of being able to tell if your cable is lossy, if there's any issues with it, maybe water's got in or there's a bad connection or something else that's going wrong. Now, one last thing we also probably want to do to test this coax is we can click VSWR, and this looks very, very all over the place, but what we can do is we've got an open now at the other end of our coax. So what I'm going to do is I'm going to put a known 50 ohm load on the end of the cable. I'm just going to use our NanoVNA load to see what this looks like, and we should get a nice low SWR. Now, we do have some bumps here going on, but you can see there that the highest peak that we have is 1.179 at over a gig. We're looking fine. This is perfectly fine. Now, the next video in this series, we're going to have a look at sweeping little filters like this one. This is a little mystery filter that I want to scan with the NanoVNA to see if it's doing what it needs to be doing properly. So join me over here in the next video, and also the previous video if you missed it, on NanoVNAs and being able to use them for all sorts of things in ham radio.